Bismillah ar-Rahman ar-Rahim, my dear students of the course Biopharmaceutics and Pharmacokinetics 2, third year students, Ajman University. I would like to welcome you again in this second part of the topic IV infusion. If you remember, let us recall something. We were talking about the equation that allows us to calculate the concentration at any time during the IV infusion, which is equal to concentration at time t is equal to K0 divided by the clearance اللي هو KL في V. This is multiplied into 1 minus E os to the power of minus KL في T. And we said that CPss is actually equal to K0 divided by KL في V. And the other information we added that the time to approach the CPss is dependent on the half-life of the drug, and that it takes very long time to approach this CPss. So we need to have a way or ways in order to reach the CPss more quickly. We cannot, for example, wait for 10 hours or 7 hours or more just to reach the minimum effective concentration as we explained previously. So there are two ways to deal with this. في عنا two ways. One is to give an IV bolus, okay, and this IV bolus can allow us to reach the CPss but at time 0. So bolus at time 0, okay, time 0, okay. So once we reach at time 0 the required concentration low CPss, we follow that by the infusion اللي بيكون فيها الانبوت يساوي equal to the output. طيب, number 2 is what we do is we give a fast infusion rate, okay, fast, so that when we reach the required CPss with this fast infusion, then we slow down the infusion rate to the normal rate so that K0, the input, is equal to the rate of elimination اللي هو output. So we will discuss each one of these two ideas to approach or to reach the CPss very quickly. First, we will use combined infusion and IV bolus administration اللي هو الكيس الأولاني, the first case. If you remember, let me draw for you the following. Okay, we have okay, why is it not drawing? Okay, we have this is the infusion rate that is supposed to give us the required CPss. Okay, this is our CPss. Okay, now what we do is this CPss, this value here, okay, we want this value to be equal to CP0, which I mean is that I want at time 0, okay, I want the concentration to be exactly equal to CPss. But what is CP0? It's equal to dose divided by V. So if I know my volume of distribution and I know the required concentration اللي هو CP0 now, then I'll be able to calculate the dose. So if I give injection at time 0, I will reach this concentration. But what happens if I don't do anything after that? I will have mono exponential decrease في concentration. That's why directly after I give the injection I have to start ايش infusion rate at K0 to maintain this concentration as steady, يعني to maintain it as SPSS. Okay, this is the idea. So let's look again at our previous example. Our target is 14.1 milligram per liter, and this can be achieved by infusion rate of 60 milligram, and the apparent volume distribution is 25 liters and KL is 0.17. Anyway, so what do we said? We said we will consider SPSS to be equal to CP0, and CP0 is equal to dose by V. So now I will consider my CP0 to be 14.1 and my volume of distribution is 25 liter. So if I multiply 25 liter into 14.1, I will get the required dose. So this is the dose that I will give. But what will I do after that? After that, I will continue with an IV infusion at the rate of 60 milligram per hour so that the concentration remains constant. But don't forget, if I just give an IV bolus and forget about anything else, this is what I will have. Mono exponential decrease with concentration. And if I give only IV infusion without anything else, this is what I will have. A very long time to reach steady state. This time, as I said, depends on the elimination half-life of the drug. Okay? طيب, the other approach. شو الapproach الثاني؟ اللي هو combined slow and fast infusion. إذن, okay, I want you to look at the following. Okay? We have time. Okay, بالhour and concentration. طبعا بالمايكروغرام مثلا او مليغرام per liter, whatever. Okay, now the first question is, what is your target? This is my target, this is my CPSS. Okay, usually, as I said, we need very long time to reach my CPSS. So this is the slow one. So what I'm going to do, instead of starting with this slow or the maintenance infusion rate اللي هو العادي, the normal one, I'm going to use fast. شوفوا, fast infusion rate. Okay, this is the fast one. So that at certain time, مثلا let's say half an hour or 1 hour, 1 hour, or half an hour or 15 minutes, so that in 1 hour I'm gonna reach the target CPSS. Then if I don't do anything, you see that what will happen? We're going to toxic concentration. That's why when I reach this point, I should continue with this slow infusion rate to maintain the concentration at steady state. This is what we will be doing. Isn't what I need to know is what is my target CPSS and how fast I need to reach it. Okay, half an hour, 1 hour. Then I will start the fast IV infusion. Once I reach my CPSS in the specified time, I will slow the IV infusion just to maintain the CPSS. Let's look at the following example. The same as previous example. Okay, اللي هو ال K0 normal is 60 milligram per hour, KL is 0.17 hour to the power of -1, V is 25 liters, CP is 14.1 milligram per liter. Okay? طيب, suppose we want to reach the CPSS in 30 minutes. 30 minutes يعني 0.5 hour because we are using hour. Okay? So what will you do? You will use the equation during IV infusion. لأنه شوفوا this point is happening during the fast infusion. صح ولا لا? So during the infusion, this is the equation we have, Cp equal to K0. هلا K0, I'm not going to write 60 because I want to know the fast infusion that will allow me to reach in half an hour. Okay, so what is this? So the unknown is here, okay? This is the unknown. We know VKL V في KEL, we know that. 1 minus E to the power of minus KL, we know that. And T is إيش؟ half an hour. طيب CP is the CPSS I want to reach in half an hour, اللي هو 14.1. So if I do that, the only missing value is here, K0. If I do the calculation, what will I get? Okay, I will get that K0 is 735 milligram per hour. طيب, I want you to be careful here because this is the rate that we want to use with fast infusion. صح? How long we gonna operate this fast infusion? Remember that it will be operated for only half an hour. يعني we are not going to use the whole quantity here because this quantity is for an hour. We're gonna use half of this. Half of this يعني almost 367 or 67.5 milligram over 30 minutes. Okay? طيب, once we do that, in half an hour we're gonna reach our desired concentration اللي هو 14.1. Then what do? I have to reduce this fast to the normal. The normal اللي will give me ايش? Will give me 14.1. يعني its input is equal to the output, the rate of elimination. And this was already calculated as 60 milligram per hour. Don't forget this. Okay? So now we learned about the two ways. But what happens, my question? Let's suppose that someone, Amira or Sally or Sarah or Judy, etc. Let's suppose that they operated this infusion, 735 milligram per hour, and then they left for a weekend, okay, while this is infused into the patient. But what will happen? Let's go back. So they did not stop at half an hour, but they continued the infusion at the same speed, at the same rate, اللي هو fast rate. Then you are going to reach new CPSS. شو هو new CPSS? Because Sally left the infusion rate at high rate, this will be equal to K0 اللي هو تاع الفاست divided by اللي هو ال V في KL أو اللي هو 0.17 multiplied into 25. طب شو هو ال K0 in this case? K0 is the first one اللي هو 735. Okay? طيب, in order to do the calculation, let's look at what will happen to my new CPSS. It will be 735 divided by 0.17 multiplied into 25 liters, and this will be giving you ايش 172.94. okay, شو مليغرام per liter. طب this is instead of ايش, this instead of 14. معناته because Sally forgot to switch down or to slow down the infusion rate, we got this very high concentration اللي هو toxic concentration, especially if you know for theophylline the minimum toxic concentration is 20, but here we have 173 milligram per liter. Okay. طيب, my question is, you are done with the infusion. خلصت الانفيوجن. So you stopped, the pump stopped, and no more drug is getting in. يعني I want you to imagine the following. Okay, this is time and this is concentration. طبعا don't forget the units. And you finish the infusion at this point. So what will happen next? Now this is a normal graph paper. What happens next is, تخيلوا هيو عنا again. Now this is the compartment model. We have KL and we have the infusion اللي هو K0. Okay, and we know the equation. But if I stop the infusion شو بصير؟ I stop the infusion. So what you have only is the elimination, right? So if you know the concentration at the time you stopped اللي هو هذا, and we will call it CPT capital. Okay, if you know CPT capital, if you know this concentration, you'll be able to calculate the concentration at any time after that. ليش؟ لأن راح يكون عندي mono exponential decrease في concentration. يعني the concentration at any time post infusion يعني after stopping the infusion is equal to, this is the CP, equal to CPT capital في E us minus to the power of minus KL في T. But remember that this T is not the normal time from here. It is the time from when I stopped. In order to say it's the time since I stopped, I have to replace this T with what? With T minus T capital. Okay, this is what I need to do. Okay. طيب, إذن if I stop at any time and I know the concentration at the time I stop, then I can calculate the concentration at any time after that using this equation. The problem is, how do I calculate CPT capital? Type CPT capital is the last point when I stopped the infusion. It's when I stopped the infusion and when the infusion was going on, يعني at both. It's the beginning of mono exponential decline and it's the end of the infusion. صح? Because of that, CPT capital can be calculated from this equation اللي هو CPT capital is equal to K0 divided by KL في V multiplied into 1 minus E us minus KL في T capital. Okay? So as you see here, we are using the equation of the infusion during the infusion because it's the last point during the infusion. Okay? If I want to know what happens after that, then this needs to be multiplied E us minus KL في again T minus T capital اللي هو from the time I stopped. طيب, imagine this. تخيلوها هاي. I will remove this. Okay. Okay, imagine this. I bring it here. شو بصير عنا؟ بصير عنا منه exponential اللي بتتذكروها CP0. I will write it again. It will be ايش؟ CP0 في E us minus KL في T. It's the same equation that we wrote before with IV bolus administration. بس هون in our new case, instead of starting from 0 time, we are starting from T capital time. Okay, so my T capital is like my CP0, my 0 time. Okay, so this is what it's talking about here, and this is our CBT capital, and this is how we know the concentration at any time following IV. We stop the IV infusion. This is how we do it. We can write it also in this way. Okay, and this is also showing you how the mono exponential fall in plasma concentration after you stop the infusion. طبعا remember also the rise in concentration here is mono exponential, that's why it's not a straight line. Okay, now this is an important example that you will see. Okay, it says if V equal to 25 liter, KL 0.17, T capital half an hour, K0 is 735 milligram per hour. What would be the plasma concentration at 4.5 hours? فهمتوا شو معنى شو حكينا هون؟ Okay, you remember when we started the fast infusion? Before we started fast infusion, اللي هو 735, and it was for half an hour, right? طيب, half an hour I stopped, or Sally stopped, and Sally did not switch down or slow down, sorry, the infusion rate. So how this is gonna happen? What will happen after 4.5 hours from the start? شوفوا here, look here. Okay, imagine that this is the fast infusion. We reached 14, let's say 14 point, طبعا this is simulograph paper. We reached 14.1 at half an hour, and then Sally forgot to slow down the infusion. She just stopped the infusion rate. The pump stopped. So what you will have is a decrease in concentration, because this is simulograph paper. We are getting straight line. Of course, the slope of this straight line is equal to minus KL. The question is at 4.5 hours. 4.5 يعني here, okay? What is going to be the concentration? How do I do that? First, I need to calculate my CBT capital, صح? My CBT capital, I already know my CBT capital because I actually made this K0 so that in half an hour I will reach 14.1 milligram per liter. Type then CP at 4.5 hours will be equal to CBT capital اللي هو 14.1 multiplied في ايش؟ E to the power of minus KL اللي هو 0.17, right? Okay, خلونا بس, let us remove this because it will not show it. Let me write it again. إذن CP at 4.5 hours is equal to 14.1 اللي هو CBT capital multiplied with E to the power of minus 0.17. طيب شو اكتب هون؟ T minus T capital, لأنه T capital half an hour and I need it at 4.5 hours. معناته it's 4 hours from the stopping of the infusion. Okay, so here I will write اللي هو 4.5 minus half an hour, and this will give you ايش؟ the following. شوف كيف بدنا نسويها في الكالكوليتر. Okay, first I will start with E to the power of, I will multiply 0.17, this is negative, multiplied اللي هو 4.5 minus half, which is 4, close, equal, and this is multiplied into 14.1, and it will give you 7.14 milligram per liter. This is what we are going to get. اللي هو 7. هاي شوفوا تقريبا طبعا what he did here شوفوا بدل ما يستخدم point, where is our calculator? Okay, here instead of 0.5 it was 0.5 something. That's why our number was little higher, 17.14, but it's very close. Anyway, so after 4 hours, which is actually the half-life of the drug, I expect انه concentration be half the concentration when I stopped. Okay, لانه if you go back to the original question, you will see that theophylline has a half-life of 4 hours. طيب, another important question is the following. Okay, and this needs a graph. I told you whenever you have a table, usually it means you need to put it in a graph paper. Look at the question. It says, following a 2-hour infusion of 100 milligram per hour. إذا أعطانا إشي هون, right? Actually, it gave us two things. إنه following a 2-hour infusion معناته T capital is 2 hours. وال K0 is 100 milligram per hour. وهاي هي الداتا. This is the data that you got. You will see that they started measuring the concentration matter at 3 hours. معناته after 1 hour from stopping the infusion. احنا stopped at 2 hours. They started collecting samples at 3 hours and measuring the concentration. What they need you to do is calculate KL and V. See how we are going to deal with this. If you put it in simulate graph paper, put the data. So at 3 hours you have 12, at 5 you have 9, etc. And then you draw the best fitting straight line, and you, if you like, you may extrapolate to this point. This is انتبهوا is not CP0. ما بنحكي CP0 is this one. No, because we know that CP0 is here, it's 0. Okay, it's gonna be 0. So this has no meaning here. هنا ملهاش أي meaning. But it will be important to us in this line اللي هي النقطة هاي اللي هي the CPT capital. Okay, this will be important to us اللي هي at 2 hours. 2 hours. This is the important to us, and we can read the concentration from the y-axis as CPT capital equal to 13 milligram per liter. طيب. Type number 2, it says we need KL and V. Now what we got here is CPT capital. Now this straight line يمثل المنو exponential decrease في الconcentration, and its slope, السلوب تاعه, okay, is equal to minus KL. إذا السلوب equal to minus KL. طيب, how can you do it? How can you calculate the slope? Take any two points على الline and it doesn't matter if you take this يعني the beginning or here or here. It's better, of course, to take too far away. For me, I would suggest that you take CPT capital, okay, اللي هي هون, okay, and the point probably that is here, okay. I don't know, this may be 2 or something like that. Okay, so take these 2 points, then take ln this number here minus ln this number here اللي هو 13 divided by, okay, 24 minus 2 يعني 22. Okay, and this will give you the slope. It will be negative, so negative number will be negative KL, and then you can calculate KL. Okay, so let's see how they did it. This is CPT capital. Here they calculated KL. Okay, طيب, after that you need now V because he's asking about V as well. How can you calculate V? Okay, so CBT capital, you know it, you know KL, now you got it, and the infusion already you have it from here. It's 100. Okay, everything is given except V. This is the missing. So if you substitute the numbers 100 milligram per hour على ال KL أي وحدة, the one I got it, multiplied the V unknown, I need to calculate that. CBT capital, of course, 13. This is KL, this is the T capital. When I stopped, you will get, in the end, you will get the volume in liters. Okay? Okay, can I try this, the same thing في Excel file? Let's try it together before we end our second part. We'll try it with Excel and try to understand what is happening. Okay? Okay, let's go back. Copy these numbers to Excel. Okay, then take them and transpose them. Transpose. أيوة شايفين؟ Transpose. Okay. Insert data. Okay, insert the chart, and I want it scattered chart. This is my scattered chart. Okay, let me remove this one. So I have time here and concentration here. Now what I will do is the following. First, I will make this logarithmic. Okay, scale, make it logarithmic, and then I will insert the best fitting straight line as exponential, and I will ask the equation. Okay, type. Now this is the equation, and this is how your line should look like with data points. Let me just, for clarity, increase the equation, the equation. Okay, what you will see, this is your slope. Your slope is equal to minus 0.087. خلونا نرجع هون نشوفها هون. أيوة minus sorry, the slope will be negative, but KL is positive, so it's 0.087, same as this one. طيب وشو هذا؟ This is, if you extrapolate to this here, this is the number اللي هو 15.486, but actually as I told you ايش this number has ايش no value, or it doesn't not no value, no, it doesn't have a meaning. Okay, but what you can do is you can use it استخدموا هذا الرقم in order to calculate CBT capital. يعني this is your CBT capital, okay, and you need the concentration at 2 hours on, then you can calculate CBT capital. شوفوا how I will do it. Calculator, okay, I will start with my E to the power of, and then 0.087, this is negative, multiplied into 2 لأنه حكالي following 2 hours in infusion. Okay, equal, it's giving me 0.84. طيب, this I will multiply it into 15.486. شوف شو بيطلع معي، 13 أو 13.012. خلونا نشوفها هون. 13. okay. So this is your CBT capital اللي هو 13 تقريبا or 13.01. okay. So this is how we can use our Excel in order to verify the information. Of course, don't forget that in any graph you do, you need to do the following. You need to add titles to axis. For example, here we can add time in hour. okay, and then we can go here and add the vertical axis as as CP in milligram per liter مثلا, and also I can add chart title. okay, chart title above the chart here. okay, here I can write اللي هو concentration versus time. okay, I can write that. ممكن I can write semi-log graph. okay, so you need to do that, and I hope by now you fully understand the topic IV bolus, IV infusion, that assumed, انتبهوا, zero order input, first order output, and one compartment model. Thank you and bye bye.